Lesson 6.4 is about nth roots. So before I begin, I want to go over some vocab. So n, that is called the index. And then the item under the radical, that is called the radicand. So again, n is the index, 81 is the radicand. I'll be using those terms later on in this video. All right, so for number 1, we are finding the square root of 81. All right, so I know that you probably just can look at that and say the answer, but I want to do this the more difficult way so that when we get to a more difficult problem, you know the process. So if I was making a tree diagram for 81, it would turn into 3 times 3 times 3 times 3, or 3 to the 4th. So again, you guys know the answer is 9 already. Whenever there is no index, there's an invisible index of 2. So another way you could look at this is the square root of 3 to the 4th. And so you are allowed to divide the exponent on the inside by the exponent, or I should say by the index, and that makes 3 to the 2nd, and 3 to the 2nd is 9. So when you divide the exponent inside by the index, then you are no longer inside the radical. All right, so something else you guys should know, whenever you have a negative with an odd index, your answer is just going to be negative, and then you could worry about simplifying. You could worry about simplifying this on its own. So the cube root of 343, if you did a tree diagram for 343, you would end up with 777. So again, you don't have to do all this. I want you guys to see the process. So if you want the cube root of 7 to the 3rd, you can divide the exponent inside by the index and get 7 to the 1st. And remember, when you do that process, it is no longer inside. That is the process that brings it outside. So the 7 to the 1st joins the negative that we already took out, and I don't need to write the exponent of 1. All right, also remember, when you are simplifying, you don't put plus or minus. You only put plus or minus when you are solving. Now for number 3, we're going to have plus or minus because it's already there. Right, square root of 4 we know is 2. And so now we can do the dividing technique that I just talked about. There's an invisible index of 2 right there. So a to the 10th divided by 2 is a to the 5th. All right, if we did a tree diagram for 243, that's 81 times 3. We know that we just did 81, so I'm just going to take a shortcut. 81 is 3 to the 4th, so 243 is 3 to the 5th. So if I'm dividing my inside exponents by the index, I get 3 to the 1st, p to the 2nd. All right, for number 5, I'm going to zoom in on some of these. For number 5, we're going to leave the negative outside. We're going to leave that outside, and I'm just going to divide. So m to the 6th divided by 3 is m squared. N to the 9th divided by 3 is n to the 3rd. When you divide, it's no longer stuck inside the radical. All right, again, when you have a negative and an odd index, you can just bring the negative outside. The reason is 3 negatives multiplied together make a negative. All right, and now I divide the 12 by the index, and I get b to the 4th. All right, you could expand this out. I would not recommend it. We know there's an invisible index of 2, so I would just divide it first. I would not expand it because you're just going to break it down later on. So dividing this 4 by the 2 gives you 4k, that whole thing squared, which is 16k squared. All right, and sometimes I prefer not to completely break down the number. 144 is 12 squared, and 12 can break down, but because the index is 2, I already know the square root of 144 is 12, and now I'm going to divide. And then this leads us into something important. We need absolute value on the p to the third part. And here's why. If p was negative, so if I didn't have that absolute value, if I just wrote this, if p was negative, then 12p to the third would be negative. But you're not allowed to have that equal something non-negative. So in order to make 12p to the third non-negative, we put absolute value on the p to the third part. We don't need absolute value on the 12 because we know that 12 already is non-negative. All right, so right below that, we have space to write the rule. The rule is you need absolute value when the index is even and, so not or, you need absolute value when the index is even and the variable, actually it's the variable's exponent goes even to odd. So I have to squeeze that in, and the variable's exponent goes from even to odd. All right, we'll see several examples coming up where that happens. All right, square root of 121 is 11. X to the 6th, take the 6, divide it by the index of 2, you get x to the third. The exponent for x went from even to odd, and we have an even index, so we need absolute value. All right, for 10, square root of 16 is 4. Ten divided by 2 is 5. B divided by, or I should say b to the 8th, take the 8, divide it by 2, you get 4. So we need exponent only on the a to the 5th. The exponent for b did not go even to odd, it went even to even. All right, so these negatives are going to join together. You can bring a negative out when you have an odd index. So the negatives combine together and just make positive. Cube root of 27 is 3. I divide 6 by 3 and I get p squared. I don't need absolute value because the index is odd, so I don't even have to think about whether anything went from even to odd. All right, 625 is 5 to the 4th. If you do the tree diagram, you get 5, 5, 5, 5. So 5 to the 4th, I divide the 4 by the invisible 2, and I get 5 squared, y, and then z squared, and now we have to figure out, did anything go from even to odd? So I'm going to simplify 5 squared, that is 25. The exponent for y went even to odd, but the exponent for z went even to even. All right, we had one like this a moment ago. Don't expand it out, just to simplify it down. So I'm going to divide that 2 by the invisible 2 there, and I just get 3x minus 1 to the first power. But because the exponent went even to odd, that's an absolute value. All right, going to divide. So I get m minus 5 to the power of 2. You could leave your answer like that. It's not too much more work to multiply that out. M squared minus 10m plus 25. So if you FOIL, you get m squared minus 5m again, plus 25. Combine the minus 5m's to get minus 10m. For 15, I would factor that. I noticed right away it's a perfect square trinomial. So I divide the 2 by the 2. I get 6x minus 1 to the first power. The exponent went even to odd, so I need my absolute value. All right, on the back, now I think some of you could do this without a calculator. Some of you can do it without a calculator and without using scientific notation. I'm going to show you guys using scientific notation or something similar to scientific notation. So when I see the 0.027, I notice that's similar to 27. So this problem would be a lot easier if we had a 27 instead of 27 thousandths. And then another thing I would do, I would just take out the negative so we don't have to deal with it. We know that whenever there's a negative and there's an odd index, you can just bring the negative out. So I'm going to change the inside to 27, and then I'm going to use scientific notation. So I had to move the decimal 3 places to make that number 27. So this isn't really 27, it's 27 times 10, and because I moved the exponent 3 times, it's 10 to the negative third. And so now I could just take the cube root of both of these. That would be, and I still have the negative outside, negative 3 times 10 to the negative 1. And when you move the decimal 1 place, that's the same thing as an exponent of 10, or multiplying by 10 to the negative 1. So I move the decimal 1 place back. Whenever you have a negative exponent on a 10, that makes the number smaller. Right, for 17, I notice, well, we have an even index this time, so when I take the square root of the negative part, that's I. Right, so now I don't have that negative to deal with. Some of you can just look at it and think, okay, that's 0.6. If it's not that easy for you, let's change it to 36, because we do know the square root of that. To turn 0.36 into 36, we had to move the decimal twice. That is 36 times 10 to the negative 2. And so now I take the square root of each part. Square root of 36 is 6. Square root of 10 to the negative 1, or square root of 10 to the negative 2 is 10 to the negative 1. And now I just multiply all that together. When you multiply these together, you get 0.6. So the answer is 0.6i. Right, for 18, I could look at that and just say square root of 0.64 is 0.8. But you could also do it this way and realize that 0.64 is 64 times 10 to the negative 2. And now we just divide all the exponents by the invisible index of 2. We have 8 times 10 to the negative 1 times p to the 5th. So that is 0.8 p to the 5th. And then I almost forgot, we have an exponent that went even to odd, so we need absolute value on that. All right, this one should be pretty quick. We divide. 8 divided by 4 is 2, so now this is no longer inside, and now it has an exponent of 2. Squaring that, we get 4x squared. All right, for 20, divide 4 by the invisible 2. So now 11y squared has an exponent of 2 on the outside, and we could multiply that out to 121 y to the 4th. All right, divide again. 6 divided by 3 means that 5a squared, when moved outside, has an exponent of 2. So that's 25a to the 4th. All right, here are some calculator problems. So make sure you know how to use your calculator. Now, without even touching a calculator, you should know that this answer is going to be between 7 and 8 because 62 is bigger than 49 and smaller than 64. Square root of 49 is 7, square root of 64 is 8. So if you put this into a calculator and you follow directions and round to 3 decimal places, you get 7.874. So make sure you know how to use your calculator. So some calculators, they do it differently. Sometimes you have to type the 62 first and then take the square root. Sometimes you have to type the square root first and then put in the 62. Again, make sure you know how to use your calculator. All right, for 23, I would just take 0.054, and I find it easier to raise that to the power 1 over 3. So cube root is the same thing as exponent 1 over 3. All right, so if you do that and round to 3 decimal places, you get 0.378. All right, so I know the final answer is going to be negative. I'm going to take 5.45, raise it to the power 1/4 or 0.25, and you get 1.528. All right, for number 6, well, you can't have an even index with a negative inside. You can't do that on a calculator. So I would just say for this one, this is not real. All right, and then finally, we have a real life application. So the police, they use the length of a skid mark to estimate how fast the car was going that created the skid mark. So this equation has 2 variables, which means they should give us 1. And they're asking us to find the speed of the car, which is r. So that means they should give us L. And if we read the problem, they tell us the skid mark was 300 feet long. So we're figuring out 2 radical 1500. They want that to the nearest 10th of a mile per hour. So 2 times the square root of 1500 is 77.5 miles per hour. And so now the cops have to figure out what the speed limit was there, and that'll determine if the person was speeding or not. All right, that's it for 6.4.